Now, to make you feel better, this is not a topic we've covered yet. I threw these up there to see if we had to cover it before we got into our last topics for tonight. So anyway, this first one up here, what you would have to do first is the parentheses. And if you have more than one, you go left to right. So the first one you run into is this one right here. We find its other end, which is down here. So we start out by focusing inside that set of parentheses, or inside the blue box. Now inside there, we still have to look for other enclosing symbols, or parentheses in this case. We have this one. We need to find its other end, which is right there. Inside there, we still look for enclosing symbols, or more parentheses. That one right there. So our first step when dealing with these problems is always enclosing symbols, our first order level of priority. So inside there, we got 5 plus 3, which is 8. Good. So we take out the 5 plus 3, replace it with 8. Now we are down to a single number in that parentheses, in the green box. So I can take out the parentheses. I don't need it anymore. The rest of the problem remains unchanged.
Okay.
Now, we're done inside the green box. We're back out to this parentheses, the red box. In there, we have multiplication and division. There's no more enclosing symbols. So step 1 is enclosing symbols. That includes the parentheses. That is our highest level of priority. Second level of priority is something called exponents. Exponents include powers and roots. Looking in this problem, are there any exponents inside the red box? No. So our third level of priority is multiplication. And multiplication and division are the same problem, so multiplying and dividing are going to happen at the same time. Inside that red box, is there any multiplication or division? Yes, there is. There's a couple of them. If there's more than one that happen at the same level, we move left to right. So we're going to do 3 times 8 first, which is 24. Now, I don't have room to rewrite the whole problem, so I'm going to cheat here right now. I'm going to erase the 3 times 8 and replace it with 24. Everything else stays exactly the same. So now we've been on that level of priority, the multiply and divide. We're still on that level. Is there anything else inside that red box that's on that level? That's multiplication and division.
24 divided by 8.
Yeah, there's division. 24 divided by 8, which is 3. So I'm going to take out the 24 divided by 8, and I'm going to replace it with 3. Again, nothing else in the problem changes. Now I've got what's in that parentheses, that was the red box, reduced to a single number. So once again, I can take out those parentheses. Note that there is already an operation before and after those parentheses, so when I take them out, that's all I need to do is take them out. So now we're back out to the bigger set of parentheses. That was the blue box. In there, we go back up to the top of our levels of priority, enclosing symbols. Are there any other enclosing symbols inside there? Yes, there is. There's a parentheses right here. So we're going to focus inside that red box. Inside that set of parentheses, are there any other enclosing symbols? No. Are there any exponents, any powers or roots inside there? No.
Nope.
So we're down to level 3, which is multiply or divide. Do we have any of that in there?
Yeah.
You bet. 2 times 3, which is 6. So I take out the 2 times 3, and I replace it with 6. Now there's nothing more for multiplication and division in there. So our fourth level of priority, our lowest level of priority, is to add or subtract. Remember, addition and subtraction are, again, the same operation. So we have 9 minus 6, which is 3. So I take out the 9 minus 6 and I put in a 3. Now again, I've reduced that set of parentheses to a single number. So I can take out the set of parentheses. Now on this side, there's an addition after the parentheses, so that side's okay. On this side, there is no operation outside the parentheses. What do I have to put in there?
Multiply.
Multiply, very good. That 2 in front of the parentheses with no symbol implies multiplication. So now that I've finished off that set of parentheses, I'm back out to the bigger set of parentheses, back out to the blue box again. Inside there, we go back through the levels of priority. Any other enclosing symbols? No. Any other exponents?
Nope.
No. Multiplication and division?
Yep.
Yes, we have 2 times 3, which is
6.
6. So I'm going to take out my 2 times 3 and put in a 6. Any other multiplication and division? That's it. So I'm down to that lowest level of priority, adding and subtracting. There's more than one, so I'm going to move left to right. 11 minus 3 is 8. So I take out the 11 minus 3, I put in 8. 8 plus 6, 14. So I take out the 8 plus 6, and I put in a 14. 14 plus 5, 19. So take those out and put in a 19. Now again, I've reduced what's inside that set of parentheses to a single number. Here at the end, there's subtraction there, so I can take out that parentheses. What do I have to do up front here?
Multiply.
Put in multiplication. So when I take out the parentheses, I put in the multiplication. So now, no more enclosing symbols, no problem. They're all gone. Any other exponents? No. Multiplication and division? Yep, there's a couple of them, so we're going to go left to right. 2 times 19? 38. So we've got 13 minus 38 minus 3 times 4 over here. Now I've got the 3 times 4. 12. I put in 12. Now all I have left is subtraction, so I'm going to go left to right. 13 minus 38. 13 and minus 38, or 13 plus a negative 38, is negative 25. Negative 25 minus 12. Negative 37. Anybody get that? Show of hands. Couple.
I got negative 4.
Negative 4. See, negative 4, I'm not sure where you varied off of that one. Like I said, the biggest mistake that people will make on these is right off the bat, they want to do 13 minus 2. Can't do that because that 2 is subtracted from the 13, but it's multiplying what's in the parentheses. Multiplication is a higher level priority. It has to happen before we can do the subtraction. Okay, so that one was fun. Let's try number 2 here. Number 2, to understand how to do it, we need to understand this symbol across here. What is it? Okay, divide. It does mean division. It's what we call a fraction bar. And it is division. It does mean to divide. But it's also an enclosing symbol. It separates part of the problem from the rest. It is telling us that we have to do everything on top first. Then we have to do everything on bottom. Then we can divide. So on top, 5 plus 7 times 5. What are we going to do first? multiplication. 7 times 5, which is
35.
35. So we got 5 plus 35, which is 40. So the top is equal to 40. On bottom, what do we have to do first?
Exponential.
There's an exponent. 6 squared, or 6 to the power of 2, is
36.
36. So 5 times 8 minus 36. And then
5 times 8.
we do the multiplication. 5 times 8 is 40. And then
40 minus 36.
40 minus 36 is
4.
4. So 40 divided by 4 is 10. How many had 10 for that one? Okay, so that one was definitely a little more palatable. Well, let's do a few more similar to them and see how you do. Using, now that we actually know what the levels of priority are and how they work, let's look at a couple more. Let's have you do that one quick. Let's take a peek. So, what has to happen first?
Multiplication.
Perfect. There are no enclosing symbols and there are no exponents. So we're down to multiplying and dividing. 3 times 9 is
27.
27. So the rest of the problem stays the same. Then what?
Left to right.
Left to right. We're down to just addition and subtraction. 17 plus 27 is 44. 44 minus 5, 39. Any questions? Not yet? Well, that's good.
Just wait.
I'm sensing some skepticism here.
We liked you last week. This week it's a different story.
I see how quickly we fall,
Yeah.
huh?
Who's we? I'm not involved in this.
Strategically distancing himself there, it looks like. Give this one a shot. What do they call that? Plausible deniability? Okay, so let's take a peek and see how we're doing. We start out at our highest level of priority is enclosing symbols. Do we have any?
Yes.
Parentheses right there. We subtract. We're going to get 348. Now we're down to a single number in the parentheses, which means we can get rid of the parentheses. Do we have to put any multiplication in when we take out the parentheses? Say no.
No.
No. Good. So now what do we have to do?
Divide by
Left to right with division and multiplication.
Multiplication and division, we're going to go left to right. 348 divided by 4 is
87.
87. Good. So nothing else changes. We replace that with the 87. Now what's next?
-5 times 7.
Okay, we could treat it as a -5 times 7. We would have to change it to plus a -5 times 7 like that. Or we can just do it as 5 times 7, which is what I'm going to do here. So that's 35. So this is 87 minus 35, which is
52.
52. Try this one. So we have the parentheses. We're going to start in there. In there, are there any other enclosing symbols?
No.
No. Any exponents?
No.
Nope. We are at multiplication division. 3 times 5 is
15.
15. Now we have the 9 minus 15, which is
Negative 6.
-6. Now we're going to talk for just a second about other uses of parentheses. We are down to a single number inside those parentheses, but I'm not going to take them out. At this point, there's nothing to do inside this parentheses. It is no longer an enclosing symbol. It's not separating part of the problem from the rest. What it is, and it's not saying we have to do something in there first. What it is right now is it is just a separator. It is isolating that -6 so that we know that that truly is a -6 and not -6, not subtract 6. So that parentheses, even though it's still there, is no longer an enclosing symbol. So now, what do we do?
Multiply 7 times -6.
The 7 times -6, which is -42. Now I'm going to put that in parentheses as well, so that we know that that is a -42. And then we have 13 plus -42, which is -29. Wonderful. What do y'all think?
Yeah.
This is fun.
This is fun?
Good.
Not bad.
Well, in that case,
Just trying to encourage you.
trying to keep my spirits up. I like that.
Yes, yes.
I'm not doing it.
I'm sensing a little bit of a lack of support between people in this class right now. Had to change that just a little bit there because I screwed up. I'm going to have you try that one quick, and then we'll move on. By the way, it's not uncommon to see the X in there for multiplication. That is not an X, that is just multiplication. So don't get confused if you see it written like that. Okay, so we have that fraction bar thing again, which tells us we have to do what's on top first. So I'm going to write that over here. So what do we have to do up there? Multiply the 5 times 7, which is 35. Everything else stays the same. Then, left, right, 11 plus 35, 46. And 46 minus 4 is 42. So 42 on top. On bottom, what do we have to do first?
Left to right is multiplication.
Multiplication and division is our highest priority. So 4 times 7,
28.
28. And then moving left to right, we do run into the 2 times 7,
14.
14. So 28 minus 14,
14.
14. So the bottom is 14. Now what?
42 divided by 14.
42 divided by 14 is 3. Any questions?
So to make that easier, it was, once I was kind of like, I don't know. So I just divided by 2, and then I kind of figured out in the end. Because I was thinking, does 14 go to 42? I don't know. So I divided by 2, and that's an okay way to do it too.
Treated it like a fraction like this and divided both of them by 2 like that.
Yeah.
Get 21. That is just fine, yes.
Okay.
Good thinking.
See, I am not drinking.
Okay, so tonight, our first main topic. We're going to talk about percents. Percents are an extremely important concept in business math and in business in general. Pretty much the last 3/4 of this class are percents and applications of percents. Invoicing and merchandising, markups, pricing is all about percents. Investing in interest and annuities are all about percents. In the business world, percents are king. Percents are actually a part of ratio and proportion, which, in my opinion, is the single most powerful concept in math. So to understand how to work with percents, we first have to understand the word percent. It's actually two words. Per, if you think of miles per hour, dollars per hour, miles per gallon, it is for each or out of. And the word cent, if you think of cents in a dollar or years in a century, that is 100. So percent literally means out of 100. So if I give you 84% like that, that literally means 84 out of 100. In fact, the origin of this symbol here, the percent symbol, actually is like that. In fact, the original percent symbol looks like that. It's actually a blank fraction or a ratio. A percent is just a ratio comparing things out of 100. So anyway, 84% is 84 out of 100. And it is just that simple to convert a percent into a fraction. Now, of course, we wouldn't leave it as 84 over 100 now that it's a fraction. What can we do to it? We can reduce it. Both 84 and 100 can be divided by 2 works. So that's going to be 84 divided by 2 is 42. 100 divided by 2 is 50. And then both be divided by 2 again. So 21 over 25. So 84% is the same as 21 out of 25. So 35% is what is a fraction? Well, 35 over 100. Perfect. And both of those can be divided by 5. 35 divided by 5? 7. And 100 divided by 5 is 20. You are correct. 7 20s. %390.
390 out of 100.
Perfect. 390 out of 100. Now you might be looking at that thinking that's an improper fraction. And yes, you're absolutely right. 100% is a whole thing. 100% is 1. So since that's bigger than 100%, we better have something bigger than 1. Now I would take it at this point and I would split that into a mixed number. 100 goes into 390 how many times? 3. It's pretty easy at this point. How many would be left over? 90. So 90 hundredths. So 3 and 90 over 100. Now we can go ahead and reduce. What can both those be divided by? 10. Perfect. Now remember to bring the 3 with. 90 divided by 10? 9. And 100 divided by 10? 10s. So 3 and 9 tenths. Any questions? Okay. Since there was some cynical comments earlier about things getting worse, don't feel bad. I was going to do it anyway. 36 2/3. How do we turn that percent into a fraction? Well, 36 2/3 percent is 36 2/3 out of 100. Now, there's actually a few different options we have here. I'll show you a couple of them. One is, if we want to get rid of a fraction, we can multiply by its denominator. Or, if there's more than one fraction, we can multiply by a least common denominator.
So if we would have taken 3 times 36 plus 2.
Now that will come in just a second here. We do want to get it in this form before we do anything. 36 and 2/3 out of 100, because that's its fraction form. But what we can do is the only denominator right now is the 3. So I can multiply the top and bottom of this fraction by 3 to get rid of the fraction within the fraction, if you will. On bottom, 100 times 3 is 300. That's easy enough. On top here, we make that 3 over 1 so that it's a fraction. What do we have to do to the 36 and 2/3? Has to be made into an improper fraction. 3 times 36 is 108, plus 2 is 110, times, we still have the 3 over 1. The 3's cross cancel out to give me 1 and 1. So I just have 110 times 1 is 110. 1 times 1 is 1. So that is simply 110. Nobody caught my screw up down here?
Yeah.
100 times 3 is 300. I think I said 300, but I wrote down 100. Some days, just so you guys are aware, at this point in the evening, the hamster refuses to get back on the wheel. So right now he's just laying beside it, trying to swat it with his paw. So anyway, 110 over 300, both of those can be divided by 10 to give me 11/30. So 36 and 2/3% is the same as 11 out of 30. Now I promised you I'd show you a second way we could do that. 36 and 2/3 over 100. We can always treat a fraction like a division problem. So we just treat that as 36 and 2/3 divided by 100. I would make that 100 over 1, so it's a fraction. And now 36 and 2/3, 36 times 3 is 108, plus 2 is 110 thirds again. Instead of dividing by 100 over 1, we're going to multiply by the reciprocal, 1 over 100. And then we can cross cancel. 110 and 100 can both be divided by 10 to give us 11. 100 divided by 10 is 10. 11 times 1 is 11. 3 times 10 is 30. So we get the same answer. I think actually doing the division is probably a little bit easier.
Where did 36 go?
36 times 3 was 108, plus 2 is 110. So 36 and 2/3 became 110 thirds.
Gotcha. Sorry.
No problem. No problem. Be nice. Okay, so let's say we have 56.25%. And I want to change that into a fraction. Well, that's 56.25 over 100. Now, just up here, we didn't like having fractions within our fractions. Well, we don't like having decimals within our fractions anymore. So to get rid of the decimal, we're going to multiply by something. Now, being that that's 0.25 and you see that that's a quarter, you could multiply by 4 and get rid of the quarter, but that's unique to this situation. Generally, we use the decimal places to get rid of it. Just like when we divide by decimals, we move those decimal points over. Same here. Now here we want to move that decimal point over 2 spots, so we'd have to multiply by what? 100, right? We'd move it 2 spots. We'd have to multiply the bottom by 100 as well. So that does become 10,000. I think that's what you were thinking there. 56.25 times 100 is 5,625. And then we have to reduce that. Now I'll let you think for a while. We're going to see what we can divide both of those by.
25.
5 and 25. Is there anything bigger? 125. I'm sure if I left you long enough, you'd all see 625 goes into both, right? If you divide it by 5 4 times, it'd be the same thing. Or if you divide it by 25 twice, it'd be the same thing. 9/16. Well, it's your turn.
So why would you wanna know 9/16? To me, 56.25% makes more sense. I can see that easier
Yep.
than 9/16. So where in business would you wanna know, I mean, how does this apply in life?
Very good question. If I'm doing calculations, there are sometimes in business we talk about ratios. If you get into accounting, you start talking about debt to equity ratios, liquidity ratios, current ratios, owner's equity ratios, debt to owner's equity, profit to owner's equity, sales to owner's equity, all those ratios. Sometimes, depending on who you're presenting to and what you're using them for, you'll get a ratio something like this, 9/16. Sometimes you'll divide it out, turn it into a decimal, and then make that into a percent, depending on what you're using it for. If you're going to be doing some quick calculations, often it's easier to have it as a fraction, and you can just set it up into a proportion and cross multiply and divide it as a proportion. And if you know a relationship in a ratio like that between two numbers, if you can set it up in a proportion, you don't have to understand any of the formulas that go with it. As long as you know that the relationships are equivalent, you can always cross multiply and divide and find missing numbers. I'm going to have you guys try these three here. Convert those three into fractions for me. You might not be completely done yet, but let's take a look at what you have so far. So for the first one, 224% becomes 224 over 100. We take out the 100. It goes in there 2 times with 24 hundredths left over. And we can reduce by 4. So we keep the 2. 24 divided by 4 is 6. 100 divided by 4 is 25. So 2 and 6 25ths. How many of you got that? Good deal. Good start.
I didn't make it a proper size.
Okay. So you had 56 25ths. That's fine. So now 18 and a third over 100. 18 and a third percent is 18 and 1/3 over 100. If I do 18 and 1/3 divided by 100, that is 55 over 3 times 1 over 100. Now, does everybody see where the 55 over 3 came from? It's just 18 times 3 plus 1 is 55 over 3. 100 is 100 over 1, so we're going to do the multiplying by the reciprocal. And now 55 and 100 both divide by 5 to give me 11 and 20. 11 times 1 is 11. 3 times 20 is 60. 11 60ths. Or 11 out of 60. How many of you got that one? A little bit lower batting average on that one. Okay. Any questions?
Yeah. So you had to put 55 over 300, right?
Over 300, yeah. You could get 55 over 300. Both of those can be divided by 5. So 11 over 60. So 625 over 100. Have to get rid of that decimal, so I'm going to multiply by 10. Now I multiplied by 100 before. Why am I only multiplying by 10 here? Perfect.
It's in the 10th spot.
Yep, it's in the 10, so it's only one decimal place. So we only have to move the decimal over one spot, so we multiply by 10. So 62.5 times 10 is 625. 100 times 10 is 1,000. Both of those can be reduced by
25.
25. If we divide by 25, we get 625 divided by 25 is 25. 1,000 divided by 25 is 40.
40.
And then
Divide by 5.
divide by 5. We get 5 eighths. 5 out of 8. What's that? 5 fourths. You probably divided around. Did you have 25 over 40?
No, I 25 over 20.
There you divided when you did the 1,000 divided by 25, you
Yeah.
had a mistake.
I took it times 100, but I still got
Okay.
it with 5 eighths. I just had to.
Oh, you said 6,250 over 10,000, and you had to reduce by 1,250 instead of 125. So what if I want to turn my 84% into a decimal instead of a fraction? Well, we said 84% means 84 out of 100. To turn that into a decimal, I just divide. 84 divided by 100 is 0.84. In fact, all of these percents are out of 100. That's what percent means. So to turn it into a decimal, I'm always going to divide by 100. When I divide by 100, all it does to a number is takes the decimal point and moves it 2 spots to the left. So if I have 59% as a decimal, I'm dividing by 100. I take the decimal point and go 1, 2 to the left. That's going to become 0.59. So what is 31% going to become as a decimal? 0.31. 600% as a decimal. 6.0, 6.00, however you want to write it. Or just 6 would be fine. How about 9% as a decimal? 0.09. 70% as a decimal. 0.70 or just 0.7 if you wanted to. 280%? 2.8 or 2.80. Gotta go 2 spots, remember. 7.3%. Perfect. 0.073. Now, here's the one where I will generally catch people. 1/4% is a decimal. Careful.
0.0. Oh,
Keep going, you're on the right idea.
0.025.
2 zeros. 0.0025. 1/4, if I change it to 0.25, that's still a percent. I haven't divided by 100 yet. 1/4 and 0.25 are the same thing. So I have to divide by 100 to move my decimal point to make it a decimal yet. I'm going to bring up a concept called benchmarks. When we looked at operations with whole numbers, I preached about estimating, having an idea of what the calculator is going to give you before you start. Benchmarks are that equivalent when it comes to percents. 1% we know is 0.01. That's a benchmark. 1/4 is definitely smaller than 1. So its decimal better be smaller than 0.01. Okay, it is break time. It is 6:21. Let's go ahead and take a break. We'll come back at 6:31 and start up again. Okay, so we've changed our percents into a decimal. We need to now go the other direction and change a decimal back into a percent. So let's take like a 0.67. A decimal technically means out of 1. It's per unit, per one item. So 0.67 means 0.67 out of every one. It's actually, well, statistical term is called a portion or proportion. A percent, of course, is out of 100. So now, if you think of our rules of fractions, to change that 1 into 100, you'd have to multiply by 100. And if you multiply the denominator or the bottom of a fraction, you have to multiply the top by the same thing. So 0.67 times 100 is 67. So that is 67 out of 100, or 67%. So we're going to establish the same pattern we did for going from a percent to a decimal. When we divided, we moved the decimal 2 spots to the left. Here, to go from a decimal to a percent, we're going to be multiplying by 100, so the decimal point is always going to move 2 spots to the right. So if we have 0.24, what's that going to become as a percent? 24%. Multiplying by 100 and moving the decimal 2 spots to the right. If I have 3.7, what's that going to become as a percent? 370. Very good. Multiplying by 100 or moving the decimal 2 spots to the right, we have to add a 0. If we have 0.2, what's that become as a percent? 20%. Good. Moving it 2 spots to the right, or multiplying by 100, we have to add a 0. 0.09, what's that going to become as a percent? 9. Very good. 0.038. 3.8%. Good. So going from a percent to a decimal to a percent is not too bad. So let's go from a fraction back into a percent. We're going to start with one that most of you will know. 3/4 is what percent? 75. Now, if you didn't know that, there's a couple of ways we could have gone about finding it. We could have turned 3/4 into a decimal. We could have done 3 divided by 4 is 0.75, and then move the decimal point over to make it 75%. That sometimes gets a little clumsy. Another way we could have looked at it is 3/4 is 3 out of 4. A percent is always out of 100. So we could look at 4 has to be multiplied by 25 to get 100. So 3 would be multiplied by 25 to get 75. So 75 out of 100, or 75%. It's not always quite so simple to figure out what number you have to multiply by, though. So let's take something like 5/8. 5 out of 8 is how much out of 100? Well, without it punching in a calculator, what would you multiply 8 by to turn it into 100? Not as simple as it looks, is it? The short way of getting that number, to figure out what we're going to multiply the 5 by, would be to take, instead of just sitting there trying to guess what do we multiply 8 by, we would just do 100 divided by 8. Make sense? And then we'd multiply the 5 by that. Whatever we got from the 100 divided by 8. So if you look at what we did here, if we look at this, this is 5 times 100 divided by 8. When we have numbers set up in a proportion like this, the shortcut, there's two numbers that are always going to be on a diagonal with each other. The 5 and the 100. Those two get multiplied, 5 times 100. Then there's a third number that's on the other diagonal all by itself, or it's diagonal to our missing number. We call this x if we wanted to. We're going to divide by that number. So it's 5 times 100 is 500 divided by 8, which is 62.5. So 62.5 out of 100, or 62.5%. This process, we talked about it briefly last week, is called cross multiply. Multiply the two numbers that are diagonal, and divide. Divide by the third number. So we might have What's that? We're going to do more examples. Don't worry. We'll get you there. Don't worry. So we have 2/5. And I want to figure out how much that is out of 100. What two numbers are on the diagonal with each other? 2 and the 100, right? So those two numbers get multiplied. It's 2 times 100, which is 200. What number is by itself on the other diagonal? The 5. So we're going to divide by 5. So 200 divided by 5 is 40. So that's the number that goes in here. So it's 40 out of 100, or 40%. I'm going to have you try a 3/16. So how much out of 100? The 3 and the 100 are diagonal with each other, so we multiply them. 3 times 100 is 300. Then we divide by the number that's on the other diagonal by itself. We divide by 16, which is going to give us 18.75, correct? So it's 18.75 over 100, or 18.75%. So let's do a fun one. 4/7 is what is a percent? So we cross multiply. 4 times 100 is 400. Divided by 7 is 57.142857143 approximately. What's that? I would round it to 57.14. So it's 57.14%. Now, just for the record, I did not have that number written down. Math calculations are about patterns. That's why I teach the way I do rather than memorizing processes. If you see the concept behind it, it's easier to start seeing the patterns. Once you see the patterns that occur, the calculations become simple. It takes a long time to get to where you see those patterns. I'm not saying it's going to happen overnight, but these calculations like this are not as bad as they look once you start to see the patterns behind it. So we can convert percents into fractions and decimals, and we can convert fractions and decimals back into percents. So now it's time to take a look at other calculations we can do with our percents. So I might ask you to find 70% of 90. In these problems, we try to always start with the percent. In fact, I'm just going to say it. We're always going to start with the percent. 70% is 70 out of 100. And we're going to set this up in a proportion, just like we did when we were converting our fractions. Now, on the other side of this proportion, we need to match numbers up with the 70 and 100. To do that, we must understand, what do that 70 and 100 mean? Well, the 100 is actually representing 100%. 100% is the whole thing, or the beginning amount or starting amount. So 100% is usually the entire thing, or what's called an initial value, where we started with things. The 70% represents a piece or a portion that we are focusing on. Now, in your textbook, they actually talk about the base, the rate, the portion, and all that stuff. I don't expect you to memorize those pieces, but to understand what these pieces mean is kind of important. So, in the problem then up here, there has to be two other numbers. The 90 is pretty obvious. The other one is the number we're trying to find. One of those represents the same thing as the 70. It represents the piece we're trying to focus in on. The other one represents the whole thing, what we're basing, the base amount, what we're basing things on. That's another way to think of the 100, is it is the base amount. Well, if we look at this, we're asked to find 70%. That's implying that what matches up with 70 is what we're trying to find. Also, if we look at this as of 90, you might want to read that as out of 90. That implies the 90 is on bottom. We're taking it out of 90. Now that we have it like this, how do we find the missing number? We cross multiply. 70 times 90 is 6,300. And we divide by the 100. It'll be 63. So 63 out of 90, 63 is 70% of 90. So for this next one here, blank is 130% of 60. I will start with the percent again. 130% is 130 out of 100. On the other side, we have to match up numbers. Blank is 130. Implies that our missing number matches up with the 130. Of 60, once again, can be read as out of 60. Implies 60 is on bottom, out of 60. Yep. And once again, to find our missing number, cross multiply. 130 times 60 is 7,800. Divided by 100 is 78. 78 is 130% of 60. Now, how is it that the portion, the piece that we're looking at, is bigger than the whole thing? Well, our percent was bigger. There you go, exactly. 130 is bigger than 100%. That's the whole thing is 100%. 130% has to be bigger than the whole thing. This one is worded quite differently, but really pretty much the same problem. 35% of 80 is blank. We start with the percent. 35% is 35 out of 100. Now we look at our wording. Of 80, think of this. 35% out of 80 implies 80 goes on bottom. Is blank. The blank has to match up with our 35. We cross, multiply, and divide. 35 times 80 is 2,800. Divided by 100 is 28. Not too bad so far? Good. So far, be nice. I'm not that mean, am I? Okay. I don't have to go back to standing at the door listening for revving engines in the parking lot before I leave at night?
Not yet.
Not yet, okay. So on this one, it's a little bit different. 52 is 40% of blank. we will still start out with a percent. 40% is 40 out of 100. This time, however, it says 52 is 40%. That implies the 52 matches up with the 40. Of blank, think of that as out of blank, implies our missing number is on the bottom there. Now you'll notice, even though the numbers are in different locations, the process is still going to be the same. It is cross multiply. 100 times 52 is 5200. And divide by the other number, the 40. Divided by 40 is 130. So 52 is 40% of 130. Any questions? So how about this one? %20 of blank is 14. Where would we start? 20%. Good. So 20 out of 100. Let's start out with the 14. Is the 14 going to go on top or bottom? It's going to go on top. We have of blank. If you read that as out of blank, implies that the missing number has to go on bottom. Or you can read it like this. 20% is 14. It seems to imply that 20% is linked with the 14. So then we cross multiply and divide. 100 times 14 is 1400. Divided by the 20 is 70. So on this one, 32 is blank percent of 40. I've been saying on all these problems we start with the percent. This one doesn't have the percent. Careful. Well, you could, you're right. But I'm gonna stay consistent. I'm gonna stay with starting out with a percent. Missing percent is just blank over 100. Now the 32 is blank percent, implies the 32 matches up with that missing percent. Of 40, out of 40, is on bottom. Now again, you'll see the numbers are in different positions, but the process is still the same. We're going to cross multiply. 100 times 30 is 3200. Divided by 40 is 80. 80 out of 100 is 80%. 32 is 80% of 40.
You know, this is easier than the way they showed it in the book.
The book uses a little graphic thing that they.
I mean, it's the same thing, but it was a little bit more convoluted, I thought.
Yeah, it is. This to me is a lot simpler. The book tries to break it down and give a separate method for doing every type of problem instead of just one method that works for everything. So for this one, blank percent of 90 is 27. Once again, I'm going to start out with my missing percent. Blank percent is blank over 100. Which one's going to go on top, the 90 or the 27?
27.
The 27, good, because I read this as out of 90 implies the 90 has to go on bottom. Cross multiply, 100 times 27 is 2700. Divided by 90 is 30. 30% of 90 is 27. Now there is something called the rate method of percents. Some of you, especially those of you closer to my generation, might be looking at this saying, that's not how I was taught to do it. A lot of us were taught something called the rate method of percents. And in the rate method, you take the percent and you change it to a decimal. So 70% here would become 0.7 or 0.70. And for this problem, you take 90 times 0.70, get 63. Well, that seems pretty simple. Let's look at this one down here. 130% is 1.3 or 1.30. Take the 60 times 1.3 is 78. Now again, that seems pretty simple. The problem is, let's jump down a couple problems to this one. So here 40% is 0.4 or 0.40. However, we do not take 52 and multiply by 0.40. For this problem, it would have to be 52 divided by 0.40 to give us our answer of 130. Same here. This is 20%, 0.20. It would be 14 divided by 0.20 to give us the 70. So if you use the rate method for percents, you have to change a percent into a decimal, and then you have to decide, do I multiply by it or do I divide by it? Even further, you run into ones like this, where you don't have the percent. Then you have to take the numbers and figure out which one divides which one. Here we do 32 divided by 40 is 0.8, and then move the decimal point to make it a percent. So that rate method of percent is quicker, and I'll be honest, that's the way I do percents when I'm doing them in my head up here. But there's a lot more chance for mistake because you have to figure out what method you're using. Are you multiplying by the decimal? Are you dividing by the decimal? Or are you dividing out first and moving the decimal point later? This method, the proportion method, is always the same. Once you figure out where to put the numbers in there, it is always cross, multiply, and divide. When we look at word problems here in a couple minutes, there's a lot of things in word problems that are simpler when we do it as proportions that are easier to line up. Now, with that said, there are a lot of applications where the rate method is extremely useful, especially when it's like this, where we have the whole thing. The 90 here is the whole thing, or a starting value, and we are looking for that portion or that piece that we are focusing in on. When we're going in that direction, the rate method can be very handy. And when we start talking about markups and markdowns, we might use it a little bit. But especially when we start talking about simple interest, we're going to be using rates rather than percents and proportions. So, since I know everybody loves them so much, let's talk about word problems. TLP Corp estimates weekly profit as 12% of gross sales. Find the gross sales in a week where profit is estimated at $495,960. Now, looking at this problem here, we have a percent. We have the 12%. Let's write that down. Now, remember, the 100 represents either a starting amount or a base amount, a whole amount that we're basing our calculations off of. The 12 represents a piece of that we're focusing in on, a smaller piece of that usually. In this problem, we have profit and we have gross sales. which one of those represents the 12? Profit is estimated as 12%. So that 12 is the profit.
Could you base that off of the is? That one is?
There isn't an is on this one, though. That's as,
Oh, as, that
but
right?
it's not is, yeah.
Is, profit, where profit is.
Weekly profit as 12%.
Okay, but down at the bottom.
Oh, where the weekly profit is estimated at? Not necessarily. No, a lot of people teach the is over of method. Those words don't always. Of is actually more reliable, because where it says 12% of the gross sales, you'd read that as out of gross sales. What that is telling us is the 12% is based on the gross sales. So the 100 is the gross sales. That's what we're basing this percent calculation on.
So the 495 then on the bottom.
The 495, what does that represent?
Profit.
Profit is estimated at 495. Profit's right here. So that 495 has to go with the profit. Well, what you got to do is you got to figure out what that 12 represents and what the 100 represent. Once I have that labeled, once I know that the profit represents 12, well, then when I find the other number, then I know that represents profit, that has to go on top of the 12. And now it all depends on how your mind works. I write down the percent and I label it. You might look at this and say, hey, this represents the profit. So I need to figure out what in that 12% represents the profit so I know where to put it. So you might think the opposite direction to figure out where that goes. But you do know that once you know that that is linked to the profit, it has to go with the other number that's linked to profit. So now we'll cross multiply 100 times 495,960 divided by 12.
4,130,000. So 41.
4,133,000, is it?
I thought it was, oh yeah, 33.
Yeah, this is exactly like Shark Tank.
Yep. So it is 4,133,000. So there's our result.
Don't deny it,
Okay, so let's make another example. Any questions on that one? Pat pays 32% of gross pay in taxes. How much tax does Pat pay in a week when gross pay is $1,800? Well, we have a percent here. It is 32%. So it's 32 out of 100. What does the 32 represent?
A percentage of the gross.
Okay. 32% of the gross pay implies that 32 is being calculated out of the gross pay. So the gross pay represents the whole amount. Be patient with yourself. It takes a while to recognize the keywords and stuff that help you put stuff in the right spot. 32% of gross pay implies it's being calculated out of the gross pay. So the gross pay represents the 100. So what's the other thing up there? The tax, right?
1,800 is,
So the 32 must represent the tax. Now we're going to pause for a second. Remember,
Okay.
this top number, the 32, is the piece we're focusing in on. Is the tax a piece out of the gross pay? Yeah, it is. The tax is always a portion of your gross pay. If we had messed this up, let's say we saw that 32% and gross pay next to each other, and we put gross pay up here. Well, the only other thing in the problem is tax. If we look at that and then analyze, is gross pay a piece of, a portion of the tax? No, that wouldn't make sense. So that would tell us that that doesn't make sense. That can't be what those relate to.
Cool.
So now we have the 1800, which represents gross pay. So that has to go top or bottom? Bottom, because bottom is gross pay. So we cross multiply. 32 times 18 divided by 100, 576. Perfect. $576 is the tax. Now, I'm going to ask this question. You might wonder, why am I asking it? Is the 576 what we're looking for? Well, the 576 represents the tax. In this problem, are we asked to find the tax? How much tax, right?
Yes.
So yes, that is their answer. That is it. There's a reason why I asked that question, because there are going to be times in these problems when that's not the end of the line. That's not necessarily the answer we're looking for. For example, let's say Stacy pays 28% of gross pay in tax. Gross pin of gross pay in tax. How much does Stacy take home? What does take home mean?
After taxes and everything.
That's what it gets to keep after tax. We're assuming that tax is the only thing taken out of Stacy's check. So how much does Stacy take home after tax in a week when gross pay is $2,200? So we have the percent, 28%. 28 out of 100. We've got gross pay in here somewhere. Which one does that link to, the 28 or the 100?
The 100, the 22's on the bottom.
The gross pay is the 100, yes. Because it's 28% of the gross pay, out of the gross pay. So the 28 actually represents what number here? The tax. So you said the 2,200 has to go on bottom because it represents the gross pay.
Yeah.
So now we'll cross multiply 28 times 2,200 divided by 100 is 616, correct? So now I'm going to ask you, is that our answer?
No.
No. The 616 represents the tax. Are we asked to find the tax? No, we're asked to find how much does Stacy take home. Can we use the tax to find that?
Yes.
You bet we can. We take the gross minus the tax. That tells us what Stacy takes home. So when you're dealing with these word problems, you have to stop and ask yourself, is what I found here what is being asked for? Yeah, well, we're going to get into some that are a little more difficult before we're done. Sorry, it has to be done. So let's say when ordering materials, Chris pays an additional %8 for shipping and handling. What is the total cost of items with list price of $790? So we have the 8%. The 8 represents what? Shipping and handling. Now, what would that 8% be calculated off from? What would it be based on?
Total cost of items.
Not the total cost, the list price. So the $790 is the list price, right? So that's to go with the list price on bottom. So we're going to cross multiply 8 times 790 divided by 100, which is $63.20. Yeah?
If it helps people, on page 191 in our book, it actually has like an identification of like, like the rate is,
Yep.
kind of saying, that it's a percentage or, I kind of found that helpful, like looking at, this is the whole thing, this is only a part of it.
Yeah, and it does, the book does break that down a little bit for you there as far as what is the portion, what is the base. They actually get into just picking out, name the base in this problem and stuff like that, and I don't necessarily care for that, but yeah, it does do a good job of helping you identify what is the portion, what is the rate, what is the base amount, or the whole amount.
Just in case,
Yep.
someone could use it.
So now here again, the $63.20 represents the shipping and handling. Is that what we're looking for? No, we want to find total cost. Can we find that from the information we have? Yes, how?
Add 60/20 to 790.
Perfect. Our $790 list price plus the $63.20 is $853.20. That is our total cost. 8 times 790 divided by 100? Okay. Peyton, Peyton receives a 4% trade discount. How much does Peyton pay for items with list price of $2,700? So we've got 4%. What's the 4 represent? Trade discount. So the 100 has to represent whatever that trade discount, whatever number it is we use to calculate the trade discount. What number would we calculate that trade discount off of? That would be the same number we'd calculate shipping and handling off of, right? Whatever that list price is. The list price is the marked price. It's what's marked on the item. You get a discount, well, you're going to take that marked price, you're going to find the 4%, and then you're going to subtract it off, right? So
So pre-discount.
yes, exactly. Remember we said that 100% is the whole thing or the initial starting amount. And the list price is the starting amount. 2,700 is list price, so I'm bottom. And we cross multiply and divide to get $108. Now, at this point, you've probably guessed that's not what we're looking for. What do we have to do to get what we're looking for? Subtract the 108. Because we're looking for how much did Peyton pay. Well, you take the list amount minus the discount to get that. Let's say Peyton still receives a 4% trade discount. What was the list price for items that Peyton pays $576 for? Now we're a couple minutes early, but we're going to take our break for you to think on this one. So we're going to come back at about 7:27 and look at this one.